Hello and welcome. Today we are going to start our journey on learning about numbers. But before we start that, let's go through the brief story of numbers. Our story starts in Rome. Romans used a number system which counted from 1 to infinity. The unique part of their number system was that they used symbols for denoting numbers. So they had symbol I for denoting 1, symbol V for denoting 5, X for 10, L for 50, etc. This number system is actually a natural number system. Natural number system is the one which starts from 1 and goes till infinity. This way of counting, although, had some problems associated with it. First problems were that for each number they had to come up with a new symbol. Right? So as the numbers grew increasingly large, they had to discover or assign new symbols for each number. So this seriously hampered their ability to count large numbers. Second problem was that the notation for large numbers grew increasingly complex. Right? In this example, MCCXXXIV represents 1234. But this donation is complex to decipher. So it was not a very good number system. For the next part, let's move to India. Indians discovered the concept of zero and came up with a set of symbols, a set of 10 symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the beauty of it was that they could denote any large number, any number imaginable, using these 10 symbols. Right? What they had to do was just append 0 in front of a number to increase the scale by 10. Right? So if they append 0 in front of 1, it becomes 10. If they append 0 in front of 2, it becomes 20. So it's a scale of 10 difference. And similarly, they could go on and come up with symbols for 100, 1000, 10,000, etc. This set of numbers is actually a whole number system because it starts from 0 and goes till infinity. Then again, there were some problems associated with this number system. For example, they could not subtract so easily, so they didn't have an answer for a question like what is 2 minus 4. To tackle this problem, integers came into being. Integers included the whole number system, which is 0, 1, 2, 3, 4 to infinity, and also included the negative numbers, which is 0, minus 1, minus 2, minus 3, etc., etc., etc. to negative infinity. All the positive numbers form the part of the positive number line, and the negative numbers form the part of negative number line. And in this number line, 0 was the midpoint. So it was a beautiful number system again, although it could not answer again some simple questions like what is 2 divided by 4. Before we proceed further, let's take this example. There are 3 cats in front of you. Out of those 3 cats, 2 are blue. So we can write a statement like 2 of 3 cats are blue. Right? This can be mathematically denoted as 2 by 3. Similarly, you have an apple in front of you. If I cut the apple in 2 equal parts, right, the resulting part is 1 of 2 equal parts of an apple, or 1 by 2 simply. So it's called half an apple. So these are called rational numbers. Rational numbers are nothing but numbers of the form p by q, where q is not equal to 0 and p and q are integers. So we can have a negative rational number as well. Minus 2 by 5 is also a rational number. So for example, 1 by 2, 1 by 3, 2 by 3, etc. And also 3 by 2, 3 by 1 are rational numbers. Right? So let's quickly move to the problem part of these number system. There was a guy called Pythagoras. Pythagoras was working on a theorem, right, which commented on the relationship between the 3 sides of a right angle triangle. So let's say the right angle triangle had sides A, B and C, where C was the longest. The relationship he came up with was a square plus b square is equal to c square. One fine day when he was working with numbers like 1 and 1 for the two small sides and wanting to calculate c, he came up with the answer of root 2. But when he tried to fit root 2 in a form p by q, where q is not equal to 0, he did not get any far. So he concluded that it is not rational. So these set of numbers which are not rational numbers are called irrational numbers. Before we move further, let's see another denotation of rational numbers, right? So if we have a rational number 1 by 2, it can be easily written as 5 by 10, right? And then I can denote it as 0.5. 0.5 is called a decimal numbers. Decimal numbers and numbers which have denominator as 10 or multiples of 10, right? And then we place a decimal from the right, which are number of zeros in the denominator in front of the 1. So if the denominator is 10, number of zeros are 1. So we put decimal after one part from right after one number. So we put a decimal before 5. Similarly, 1 by 8 can be written as 125 by 1000 and we can write it as 0.125. For numbers like 2 by 3, right, if you calculate, it will come up to be 0.666666, etc. These are denoted as 0.6 bar. Similarly, 1 by 6 can be written as 0.16 bar, which is 0.1666666, etc. So these are again rational numbers, and if you are talking in terms of decimal numbers, all decimal numbers which are recurring or are terminating are rational numbers. So if you have a decimal number in front of you, you can easily say whether it's a rational number or not. If the digits terminate, so for example, if it is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then it stops there, right? So it is a rational number. And if digits recur, for example, if it is 0.1, 2, 3, 4, 6, 6, 6, 6, and 6 keeps on recurring, or for example 0.12, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3 parts keeps on recurring, right? Then again it's a rational number. Now let's see how can we, if given a decimal form, how can we convert it to a fraction form. So if given 0.5 or 0.125, it's very simple. We know 0.5 means 5 by 10, right? And then we can simplify the fraction, which is divide numerator and denominator both by 5. We can get 1 by 2, right? But for numbers like 0.16 bar, it's slightly difficult to convert to p by q. So to do this, what we do is we first multiply it by 10, right? So we get 1.6666, which is 1.6 bar. Then again multiply it by 10, so we get 16.6 bar, right? So one thing which you have noticed is that what we have done is we have the decimal part, the part after the decimal is same in both of these equations. So now we can easily subtract. So 100x minus 10x, which is 16.6 bar, minus 1.6 bar is equal to 90x is equal to 15. So x comes to be 1 by 6. Right. So generalizing it, what we do is we multiply the given number by multiples of 10 such that the part after the decimal becomes the same in at least two equations, and then we subtract the equations and get the answer. Right. Let's move on to irrational numbers. So do you remember what we defined irrational numbers as? We define irrational numbers as numbers which are not rational numbers, right? So by definition, irrational numbers are non-recurring, non-terminating numbers. Numbers which cannot be expressed as the form p by q, where q is not equal to 0, are called irrational numbers, right? So numbers like pi, and you know pi as, when you calculate the circumference of a circle, you calculate it as 2 pi r. So pi there is an irrational number. Let's see. Pi, if we calculate pi, it will come to be 3.141592, etc. Right? So you notice that it is not terminating and non-recurring, hence it's an irrational number. Similarly, numbers like root 2, root 3, root 5, etc., or cube root of 2, cube root of 3, etc., are irrational numbers, right? root of any prime number is an irrational number. Now if you multiply rational number with the irrational number, you always get an irrational number. If you multiply rational number with a rational number, you always get rational number. But if you multiply irrational numbers with an irrational number, right, you can get rational number or an irrational number. Let's take an example. If you multiply root 2 with root 2, you will get 2. Root 2 and root 2 both are irrational numbers, but the resulting number that you have got, which is 2, is a rational number. Right? If you multiply root 2 by root 3, which both of these are irrational numbers, you get root 6, which again is a irrational number. Rational numbers and irrational numbers together are called real numbers, right? And there's one small thing which it doesn't answer, which is if we have to solve for x square plus 16 is equal to 0, right, and solve for x, how will you go about it? You'd say x square is equal to minus 16 and x is equal to root of minus 16. Right? Real numbers don't define roots of negative numbers. Right? So to tackle this problem, let's break it down. X is equal to root of minus 16. We can write it as x is equal to root of 16 into root of minus 1. Root of 16 is 4, right? And let's define root of minus 1 as I, where I is iota. We can write x is equal to 4i. Now this is 4i is an imaginary number. So we define complex numbers. Complex numbers are the numbers of the form a plus bi, right, where I is defined as root of minus 1. Right? In this notation, a is the real part and bi is the imaginary part. And you can plot it on a graph with a real axis and an imaginary axis, and you can plot it like this. So to sum it up, what we have learned in this video is, we learned about natural numbers, which are numbers from 1 to infinity, right? And then we said 0 is a necessary part of 0 must be introduced in this number system. So when we introduce 0 to infinity is whole number system. Then we introduce negative numbers, right? And together with the whole numbers, they became integers, right? Then we introduce fractions, which is 2 by 3, 1 by 2, which are rational numbers of the form p by q, where q is not equal to 0. And then we found that some numbers don't fall under that system, and those are called irrational numbers, right? Rational numbers and irrational numbers together are called real numbers. Okay? And then we also defined numbers like root of minus 16, which is 4i, which are not real numbers. Those are called imaginary numbers. And when you mix imaginary numbers and real numbers, these are called complex numbers. Right? So that is all in this video. In the next session, we'll go through our number systems fundamentals and concepts. Thank you for watching. Bye. Have a good day.